The science fiction writer Isaac Asimov once said that there are two ways to tell if somebody is a chemist. The first is to ask them to pronounce the following word. Now, for those normal people out there, they would look at this and focus on union, as in unionized, like electricians or plumbers or something like that. A chemist, though, would look at this in a completely different way. We would focus on the word ionized. If something is ionized, it means it's a particle that's got a positive or a negative charge because it's lost or gained electrons. So if something is unionized, that means that it doesn't have a positive or a negative charge. The second question, which it took a lot longer for Isaac Asimov to explain, is what is a mole? Is it this guy? No. What about this? No, wrong again. Ah, mole. No, but tasty. Oh, what about a CIA mole? No, not in chemistry. Okay, so if a mole is none of those things, what is a mole to a chemist? Well, to a chemist, a mole is a number. What? How can a number be a word, or how can a word be a number? Well, it's not so bad. You're familiar with words that are numbers. You know what a dozen is, and you know what a pair is. These are words that we associate with numbers. And if you lived a long time ago, you might even know that a score represents 20. So 87 years ago was 87 years ago for the Gettysburg Address. So numbers can be represented by words. Okay, great. So the mole is a number. What number is it? Well, the mole number is 6.02 times 10 raised to the 23rd. To get an idea of what this number actually looks like in sort of ordinary digits, give me a second. So let's see, 3, 6, 9, 12, 15, 18, 21, 22, 23. Okay, so that's a pretty big number. Well, it turns out that that number is really important because that number represents the number of carbon atoms in exactly 12 grams of carbon. This type of carbon? Yeah, it turns out we use carbon sort of as a benchmark. We could have looked at a mole of anything, hydrogen or helium or Britney Spears CDs or whatever. You can have a mole of anything, but by definition, chemists tend to like to use carbon. So 12 grams of carbon contains 1 mole of carbon atoms. Now, that simple fact isn't all that interesting or useful. What is useful is that each element, like hydrogen or carbon or nitrogen or iron, has atoms of a specific mass or a specific weight. And so if a mole of carbon atoms weighs 12 grams, a mole of helium atoms end up weighing 4 grams, and oxygen atoms end up weighing 16 grams, and so forth. So now we have a standard number of atoms, a mole, which is equal to a known mass, like 12 grams for carbon. Now, it turns out that being able to relate a mass, like 12 grams, to that number, 6.02 times 10 to the 23rd, has a lot of uses. For instance, stuff like this, chemistry calculations. I could go into that, but if I did, I'd have to charge you tuition. Okay, so the number of carbon atoms in 12 grams of carbon is equal to a mole. But that number has another name to it. Chemists call this Avogadro's number. Avogadro's number, 6.02 times 10 to the 23rd, the number of particles in a mole. Well, this number was named after Avogadro because he discovered it, right? That's the way things work. Well, no. Actually, Avogadro's number was first determined by a student of Avogadro. He just liked his teacher so much that he named his discovery after his teacher. And this is the most important lesson that I try to teach my students, that if they go on to discover something fantastic and they get to name it, I want them to name it after me. So someday there will be a Winkleman number. We all have our dreams, don't we?